A disclaimer to start with, which is just take everything I tell you with a little pinch of salt. Most of the things are actually, some of them are prognosis, some are actually very nice and true. And it's very true. I've been here before, I think about a year ago, to present Gabather. And Gabather stands for GABAA Therapeutics. We are, and I like to point this out, we are a Swedish company, classical spin-out from academia, from Lund University actually, and University of Copenhagen. We do work in the area of mental health in general and drug discovery and development. We are localized in the AstraZeneca facilities in Södertälje and actually in the old labs. And we have developed by now from actually, that's something that's very much worth mentioning, from a bench to bedside. So we are not an in-licensing, out-licensing company. We develop the molecules ourselves and we develop them into a candidate drug, which is now ready for phase 2 trials next year. And we've been at Nasdaq First North Growth since 2018. And the area we work in, I think most of the people here in the audience might be familiar with it, that mental health is an increasing problem in all societies all over the world, in particular in the northern part of the world. 1 in 4 people will experience some form of, perhaps not too severe, but mental health issue anyway. They start at the age very early, so it's a medical problem that starts actually at a young age and accompanies you all the way to old age. If you think about age-related diseases like Alzheimer's disease, the societal impact is enormous. I cannot understand. I was at a meeting yesterday, and the guess is that for each patient that is suffering from a debilitating mental health issue, there are at least 3 people in the family or caretakers who are also involved whose quality of life is reduced. And this is particularly the case in neuropsychiatric disorders of children, which was what I was engaged in yesterday. And the socioeconomic impact is, of course, huge. And of course, let's not forget, there's a large taboo. Not everybody likes to talk about mental health issues. They're rather ignored. And remember that usually when I go in an audience, everybody will know how many people die due to car accidents in Sweden every year. It's about 300. But nobody knows how many people actually take their own life because of depression or related psychiatric disorders, which is actually 5 times that number. So there's a large unmet medical need. And this is the problem we're trying to address. I think there's a huge room for improvement. The drugs that we have, some are good. Most of them have some side effects. Some of them have severe side effects. Some of the disorders that we're going to talk about have no real treatment. And there's a large interest, of course, in finding new therapies. And there's a lack of precision. Many of the drugs have a lot of side effects. So the team that wants to address the system is actually Gabather is a very, very small company. We're only 3 people in management. That's myself, Christine, and Stefan. And I just put the slide up. We all have our background in the neurosciences and in this field. All of us at AstraZeneca, of course, being in Sweden for many years. And that we don't run away with the project. We have actually a board of directors that takes care, that makes sure that we do the right things. And it's very nice. I just would like to point out that we have 2 new members to help us with the next phase of the development of the company. And Bert Juno, who's actually the founder of Gabather, he's actually here today. And he can give you a bigger picture during the break about Gabather. It's very nice to have him around. I cannot avoid to make it a little bit technical. I don't want to do it too nerdy, this presentation. In a very simplified way, the neurotransmitter GABA is the brake in the brain. Glutamate is the accelerator, and it's a famous excitatory inhibitory balance that you need for a brain to work in a proper way. And Gabather comes from GABAA Therapeutics. Our compounds target this receptor system very specifically, very potently. And to make a very long story very short, so we have developed 1 clinical candidate ready for phase 2 trials. It's GT002. We have very interesting data and preclinical models for learning and memory. Those are actually quite fascinating models. Can talk about it in the break if you're interested. We've completed now 3 clinical trials in phase 1. in healthy volunteers. And summary is, this is a well-tolerated, safe drug candidate. It is orally available, has a good pharmacokinetic profile. We've patented both the product process and synthesis, and we also patented the pharmaceutical development. And this picture here, which looks like a omega-3 fish oil capsule, is actually GT002. It was actually a big bottleneck in the development of the GT002 to develop a proper formulation. We did, and we patented it also. And this is a very busy slide. The key thing I want to point out here, in the number of disorders that you see here in the first row, everything from Alzheimer's disease to schizophrenia and depression, they're all of them common. In all the symptoms that you have in the columns, they all have some form of dysfunctional cognition. And there can be anything that, if you're very stressed, you will have difficulty on remembering or learning. And of course, diseases like Alzheimer's disease is per definition a disease also of cognition. And that's why GT002 is a very interesting candidate. If we can actually improve learning and memory, then we can actually target a whole range of neurodegenerative diseases. Not to say that this is a miracle cure, it's just to say that the options and the potential partners, the people that talk to us, is this compound interesting for in-licensing? They are people that work, they are companies that are working with all these indications. We have, as a clinical strategy, we have, since we have focused on the cognitive deficits that you have in all these disorders, we focus very much on imaging techniques at EEG, so electroencephalography to measure the electrical activity in the brain, and MRI and magnetic resonance imaging will make where in the brain are you using most energy. And this has been our focus and activity for the last 2 years. And in the clinical trial that we've done in healthy volunteers, which we've completed now, we're getting the data together. And I think this is actually pictures from our own study that we actually did. This is how it looks when you take an EEG, and what you actually do is you take the whole healthy volunteers, you apply the electrodes, and you put them into this tube. And this poor person not only has to lie in the tube for a while, he also has to do tasks related to regarding memory, and then you record the signals from the brain, you analyze them, and it's called a target engagement study, because when we went out to partner the project, then the pharma people that are interested in this kind of project, the first thing they want to see, you have to show us that your candidate drug engages the target in the human brain, and this is what we went out to prove via EEG and fMRI, and we did so. And this is some of the data which literally, if this was a piece of paper, it would still be warm, because this data is so recent. And what you can see is here is what we're looking at, the effect of the drug after 2 and 4 hours. And what we're looking at, and we're still doing this, does it modify the electrical activity in the brain energy, and does it modify the energy consumption in the brain after 2 and 4 hours? And of course, does the effect disappear again? And I think from the data that we've already now is that we have done it, and we do believe, and that's a message actually I want to leave everybody with, that we do believe that our approach, a window into the brain, not into the mind perhaps, but for sure into the brain activity, you can do with neuroimaging. And I myself have worked in this drug discovery business for 30 years of my career. And I must say that what is coming out now, and in particular with the combination with AI technologies and the application to data image processing in neuroimaging, is quite fantastic. So what I used to work with 30, 20 years ago seems a little bit like Stone Age now. It's nice. So I think what we had to prove, and that's what we're going to go out now to the partnering meetings in the next months, is that we do have target engagement of the human brain with this drug candidate. Again, I repeat myself, this is a safe and well-tolerated drug that is orally available and penetrates the CNS. So that is actually very nice. And to come back to the previous talk regarding about risks, it's no reason to hide away that if anybody would ask me from 1 to 10, is drug discovery a risky business, I would give it a 10. It's very risky. Everybody knows that. But to add up to your information, within drug discovery, on a scale of 1 to 10, CNS, I would also put it a 10. It's a very, very difficult field. And it's not because the other ones are easy, it's just more difficult. But the unmet medical need is still there, and so big. And the reward is, of course, still there. This is another representation of the data I'm working on now. We did the study comparing our drug candidate with a reference compound. What does it do in the brain? And it's not to confuse anybody with colorful pictures. The whole idea is that this is the way we can study where in the brain our compound actually has an effect. And this is actually an analysis of EEG data. And this is a particular frequency, not to be, again, too technical. You can do different frequencies in the brain. They're responsible for different activities. But what is interesting is that at the level where we're analyzing this now, we're getting our data out, is actually we're looking at different states of the brain, i.e. relaxation, related to anxiety, calmness, and so on. So it's a completely different level of analysis, because we're going from this level to the next higher level, which is we're looking at functional connectivity, and there we got a lot of interest from particular people from the KI here in Stockholm that are working in this area, and actually looking into the brain. How does the brain actually work at a level where you're actually starting to look at energy levels in the different regions of the brain and connections between different regions of the brain, and how the drug modulates it. Long story short, we have finished 3 trials. We got very good IP coverage, both in composition of matter. What have we done? So far, the 3 clinical trials. We finished our last clinical trial now. And most interesting for you that you're sitting here, what can we do next year, since we're in new abbreviation? So we're going straight forward into a licensing agreement for GT002. We are not going to bring this to market. We want to bring this to a partner for clinical phase 2 trials. So we're never going to go into the large phase 3 trials. We do have pipeline compounds that are waiting to be developed, depending on the budget that we get in. And what can we expect then in 2024 on the activities? We have quite a lot of things that are sort of in the starting blocks. We got clinical trials lined up for schizophrenia in different clinics. We got dementia trials here in Sweden that are ready to go. We look for third-party funding. And of course, the proof comes with the pudding. We want to get a licensing agreement within 1 year. And I think 1 year from now is actually a fair time frame. And just to tell you how much is in these projects, the biggest project, the most successful one, was a Biogen Sage Therapeutics deal with $1,500 million as a phase 2 trial. And the interesting thing about this particular agreement, not only was it a lot of money, but it was, of course, exactly the same target, GABA receptors, that this particular drug from Sage, Zuranolone, targets. So this is what you can get out of a project targeting this kind of receptors. And of course, I'm biased, but I think that the pharmacological properties of our drug are at least as good as the one from Sage, if not better. So we are very much looking at partners right now. One thing I have to add, and this is a learning process for us, because when we started this project, AI was not so hot. But I can tell you that AI-assisted neuroimaging is coming really, really hot, and it's really exploding in the last year at least. And it's, traditional jobs like radiologists in the hospitals will disappear within a year or two, and we got some very interesting partner proposals to help us with a huge amount of data that we have, and to see if we can do a much more advanced data analysis with AI. And then as an opportunity, I asked, talking about AI, I asked ChatGPT, if you put this into what is it, the question is, how much is it worth? And of course, ChatGPT, being rather chatty kind of software, it analyzes that its drug development is expensive and time consuming. Well, big deal, we knew that. But it comes up with a figure of around 50 million to 150 million US dollars to get ready for phase 2. So roughly where we are now. And I can say that Gabather has used a fraction of 50 million, maybe 10 million over the last couple of years to get where we are. But this gives you a good idea is what would be the starting point if you start negotiating about the value of your project. And this is the investment opportunity on the rights issue that is ongoing. What we want to use it for is, of course, phase 2 studies. We want to both partner, but we also want to stand on our own feet and be able to run them ourselves. We want to do business development quite extensively right now that we got the data in. And of course, we still need the runway to keep us going. So what happens next? We are packaging the bundles together with the data that we have with GT002. We continue with the EEG and fMRI analysis. I just shown you a little snapshot of that. The roadshow is starting actually January 6th this year already, and we got 3 large soft money applications out. We expect to get some information very, very soon. We're working also together with bigger consortium. And of course, we're preparing the patient trials here in the Nordic countries in Sweden for the next, in 2024. And that is basically my take-home message. I'm sorry for the rush. I only got 15 minutes. We believe that neuroimaging is, and combination with AI, is indeed the way forward for us to go, also for the pipeline compounds that we have. And I think that our ambition is to always delay the progression of the disease. We will not be able to come with a cure for any of severe neurodegenerative diseases with our approach, but we will come with a safe approach with that can delay definitively the progression of the disease and address the symptoms of the diseases, which is actually very much in agreement with many of the people from the KI community we've been discussing with. And I think this is my last slide, and I just want to leave you with this idea of a window in the brain. I don't know, I've fallen in love with this idea. Not that we think that we are Isaac Newton that actually discovers new things by putting the light through a prism, but definitively the way that we are looking at the brain activity now is indeed a window to the brain. And if you look at fMRI, you're actually very close to be able to track what a thought process or an emotional process, and you're able to look how your candidate drug actually acts. And with this, I thank you for your attention and your patience getting through the whole English process, and all the details of the transaction are on our website at Gabather. And I thank you for your attention.
Tack så mycket. Ja, jag ser redan någon som har signalerat. Varsågod.
Thanks for an interesting presentation. From a research point of view, I'm a researcher myself. I'm here.
Oh, sorry.
Hi. I just want to, in the consortium, you have no psychiatrist, and you're aiming at different diseases with a heavy, I would say, symptomatology, both dementia and schizophrenia, whereas you have of course, the effects on cognition in all different psychiatric diseases. And I just wonder why you picked the most difficult diseases.
Well, that is because it depends also on the medical contact and the opinion leaders that we have. So, for example, cognitive deficit in schizophrenia is a little bit of the holy grail. That's the one that actually everybody is interested in a challenge to test. So that is how that came to be. And it literally, you know, the development of Gabather is we have gone totally unbiased into what indications we wanted in. This comes from a chemistry department. We synthesized the molecule, and then we said, okay, let's see in what models it can be the most interesting one, and that way it was directed into what indications it can be on later. It can be tried on as an experimental medicine later on.
Okej, vi har ytterligare en fråga. Varsågod.
On one of the earlier slides you said that you had seen positive effect in learning memory. Then I wonder, is that in animal models or is it in humans? Because the only humans you have studied is healthy individuals.
That was in the slide that said preclinical data effect on learning and memory. So it was in animals.
What is it that you've seen? And what is the extent of betterment in memory and learning?
Well, it's the classical memory test that you have in rats that we have seen positive effects. It is not in humans. We have exposed the healthy volunteers, but it's very difficult to see effects on learning and memory in healthy volunteers.
Fler frågor? Jag skulle vilja highlighta en sak. Du sa att erbjudandet har viss tidslimit. Du hade datum här för de som är intresserade så att du förstärker det.
Ja, det är riktigt. Det är, subscriptionperioden slutar den 20 december.
Ja, precis. Det är imorgon.
Exakt.
Ja. Så att alla har det klart för sig, om ni som är intresserade och ni som gärna vill veta mer. Ta tillfället i akt och gå in på bolagets hemsida där ni kan informera er ytterligare om det är så att ni önskar det. Har vi någon ytterligare fråga? Nej. Någonting du vill lägga till, Michael?
Nej, jag tror jag var tacksam att alla kom på så mörkt och så sent när ni lyssnar på ett långt engelskt föredrag. Jag hoppas det inte blir för nördig, men jag är faktiskt ganska stolt att få komma tillbaka till den previous talker här. Han pratar mycket om risk. Det är inte många substanser som börjar på labbet och når faktiskt så långt till att vara klar till fas 2. Det är faktiskt en absolut minnetal. Och jag tycker det är, jag tror det är ganska bra fixat av en liten bolag som har till max 5 personer. Jag sitter på gamla AstraZeneca-lokaler där vi hade CNS-forskning i 20 år. Och det är en 4-våningsbyggnad med 400 forskare. Och vi försöker göra ungefär samma sak.
Tack för att du kom hit. Vi ber att få önska även dig en god jul.
Tackar.
Tack.
Tack så mycket.
Tack.